Now we'll be looking at multiplication of modular arithmetic, and our first example is 3 times 6 mod 5. So 3 times 6, which is 18 mod 5, 18 mod 5, which means that under mod 5 our answer should be either 0, 1, 2, 3 and 4. So this is how our answer should be. So our answer can pick any of this value. So 18 mod 5 means that 18 divided by 5. So 18 divided by 5, 5 goes into 18, 3, remainder 3. So let's say, so therefore 18 mod 5 is equal to the remainder 3 mod 5. The next example we are going to consider is, let's say, negative 2 times 9 mod 7. Negative 2 times 9 is negative 18. So negative 18 mod 7, we realize that you are going to add this 7 to negative 18 until you arrive at a positive number, or you go by, let's call this method 1. You go by 7 minus 18 mod 7. 18 mod 7, 7 goes into 18, 2 times 7 times 2 is 14, so 2 remainder 4. So 7 minus 4 is 3 mod 7. And indeed 3 lies within the modular value here. Mod 7 is 0, 1, 2, 3, 4, 5, 6, where 3 is inside mod 7. Okay, the next example we are going to consider is, let's say, 13 times 3 mod 5. 13 times 3 is 429. 429 mod 5. 429 divided by 5, we are going to get a remainder of 4. So 4 mod 5 is the answer. Let's look at this next example. Let's say 5 times 7 mod 2. 5 7 is 35. 35 mod 2. 35 mod 2. 2 goes into 35. Let's say 17. 17 times 2, we have 34. So 2 goes into 35, 17 remainder. So 17 remainder 1. So therefore we have 35 mod 2 is the same as 1 mod 2. So this is the remainder when 35 divides 2. The next example we are going to consider is 45 times 6 mod 4. 45 times 6, we have 270 mod 4 and 270. So 270 here divided by 4. So we have 67 remainder 2. So 270 mod 4 is the same as 2. Write the remainder. Remainder is the answer. 2 mod 4. And this is your final answer. Our next objective, we will be looking at division of modular arithmetic, and we are going to consider the first case called the divisible cases. So let's say our first example, let's look at a question like 18 divided by 9 mod 7. So we know that our answer should lie within, now mod 7 is 0, 1, 2, 3, 4, 5 and 6. So our answer can be any of these values. So let's go. So 18 divided by 9 mod 7. Now The first case, which is divisible, means that 18 divided by 9. You can clearly see that 9 here can divide 18. So since 18 can be divided by 9, so 18 divided by 9, we have 2 mod 7. And 2 mod 7 is the same as 2, because 2 is less than 7. And since 2 is less than 7, our answer is still 2. So we can leave it like this. The next example we are going to consider is, let's say, 50 divided by 25 mod 5. 50 divided by 25, 25 goes into 50, we have 2 mod 5, and 2 mod 5 is 2. Now the next example we are going to consider, let's see the third example. We have 78 divided by 2 mod 4. 70 divided by 2 mod 4, 78 into 2, we have 39. 39 mod 4. So 39 mod 4, 4 goes into 39. So the remainder is what we are going to write as our final answer. So we have a remainder of 3. So when 39 divides 4, we get a remainder of 3. The next one, let's say 300 divided by 12 mod 11. 12 goes into 300, we have 25 mod 11. And 25 mod 11, we have a remainder of 3. The next one I'm going to consider is, let's say, 75 divided by 5 mod 6. 75 divided by 5 mod 6. So 5 into 75, we have 15. And 15 mod 6. 15 divided by 6, we have 15 here divided by 6. So 6 goes into 15, we have 2, remainder 3. So the answer to this problem is 3 mod 6. Now under case 2, we'll be looking at improper fractions. A case like 4 divided by 7 mod 5. Now it is because 4 divided by 7 is impossible, we are going to get a decimal. You are going to add this number, the modal value here, to 4, or you keep adding 5 to 4 until you get a number that can divide, that 7 can divide. So let's see. So this, we have two ways. Let's say method 1. So 4 divided by 7 mod 5. So 5 plus 4, you have 9 divided by 7 mod 5. Then you add 5 again, you have 14 divided by 7 mod 5. Now you can clearly see that 14 can divide 7. So 14 divided by 7, we have 2 mod 5. And this is your final answer. Or let's look at the second method. 4 divided by 7 mod 5. Now with this, since the number 4 here, the second method is saying that since the number 4 here is smaller than 5, you first of all find the mod of this number. Now the mod of this number, 4 under mod 5 is still 4. 7 under mod 5 is 2. So this is how we go. So 4 under mod 5 is 4. 7 under mod 5 is 2, because 5 will go into 7, 1 remainder 2. And 4 divided by 2 is 2. So that's the answer. Or you can also say that 4 divided by 7 mod 5. 4 plus 5 is 9. Now 9 under mod 5. 5 goes into 9, 1 remainder 4. And 7 under mod 5 is 2. 4 divided by 2 is 2 mod 5. So you can also do it this way. Now let's look at the next problem. Say 3 divided by 6 mod 15. So since 3 divided by 6 is impossible, you are going to add 15 to 3. So you have 18 divided by 6 mod 15. And 18 divided by 6 is 3. And 3 mod 15 is 3. So you leave your answer like that. The next one we consider is 4 divided by 8 mod 12. Since 4 divided by 8 is impossible, you add this 12 to 4. So 4 plus 12 divided by 8 mod 12. So 4 plus 12 is 16 divided by 8 mod 12. 16 divided by 8 is 2 mod 12, and 2 mod 12 is the same thing. The third one I'm going to consider is 3 divided by 4 mod 9. So since 3 divided by 4 is impossible, you add 9 to 3, making 12. So let's say 3 plus 9 divided by 4 mod 9. And 3 plus 9, we have 12 divided by 4 mod 9. 12 divided by 4, we have 3 mod 9. And 3 mod 9 is still 3.